I'm going to begin this briefing with a sentence I never imagined myself saying in public. A sentence that, even a few months ago, would have placed me firmly outside the boundaries of scientific credibility. The object we are tracking, designated 3IATLAS-b, the second interstellar visitor recorded in our era, has begun exhibiting orbital behavior that should be, by every law of celestial dynamics we have mastered, completely impossible. I don't mean unusual. I don't mean poorly understood. I mean impossible in the strictest physical sense of the word. Its motion violates principles that have been tested, verified, and relied upon for centuries. And yet the data does not lie. Dozens of observatories across the globe, from Mauna Kea to La Silla to the Deep Space Network, have independently confirmed the same measurements. The numbers line up too perfectly, the signatures are too consistent, and the deviations too precise to dismiss as noise. Whatever 3I/ATLAS-b is, whatever its nature or origin may be, it is not behaving as a comet, asteroid, or any natural interstellar debris ever has. Before we confront the implications of that, we must understand the foundation it is defying. Orbital mechanics is one of humanity's oldest and most reliable sciences. Johannes Kepler defined the shape of orbits, ellipses governed by mathematical relationships between distance and period. Isaac Newton gave us the universal law of gravitation. The equations describing how masses attract and accelerate, Albert Einstein, refined those equations under extreme conditions, giving us small corrections that become important near compact or energetic bodies. Together, these principles form a framework so sturdy that we have used it to land spacecraft on distant worlds, slingshot probes around giant planets, and guide missions across billions of kilometers with accuracy so sharp we can predict arrival times down to the minute. Nothing in that framework has ever failed when applied correctly, not once, until now. Our first indication that something was deeply wrong with 3I/ATLAS-b came on November 2nd during what should have been a routine trajectory refinement. Typically, the longer we track an object, the more precisely we can model its orbit. Minor uncertainties shrink, parameters sharpen, and the predicted path converges toward a single consistent solution. For 3I/ATLAS-b, the opposite happened. The refinement algorithm refused to converge. Dr. Elaine Hartman at the Jet Propulsion Laboratory oversaw the initial processing. She assumed the issue was a calibration error, maybe a timing offset in a telescope CCD, maybe a software mismatch between tracking stations. She spent 48 hours reprocessing raw observational data, cross-checking every independent data set. Nothing changed. The numbers held firm. The object was not where gravity said it should be. The first discrepancy was small, only around 1,600 kilometers, not insignificant, but not catastrophic. The kind of anomaly one might attribute to minor outgassing if the object behaved like a comet. But 4 days later, that deviation doubled, then tripled, then grew to nearly 19,000 kilometers by November 11th. As of this morning, the difference between predicted position and actual observation is approximately 41,000 kilometers, an error greater than Earth's circumference. If this were a spacecraft we were trying to rendezvous with using our standard gravitational models, we would miss it by a margin large enough to overshoot our own planet. What makes the situation even more alarming is not simply the magnitude of the deviation, but its pattern. If this were measurement noise, we would expect random scatter, sometimes ahead of the predicted path, sometimes behind, left, right, no directional consistency. Instead, 3I/ATLAS-b is consistently ahead of schedule and consistently offset toward the inner solar system, toward Earth. The shift grows in a remarkably linear trend, which indicates a persistent force acting over time. Dr. Ray Peterson at MIT calculated the acceleration required, approximately 0.7 millimeters per second squared, a tiny push moment to moment, but catastrophic accumulated over weeks. The total velocity change is already over 1 kilometer per second for something estimated to weigh tens of millions of tons. that should be physically unachievable without deliberate propulsion. Naturally, the first hypothesis we tested was outgassing. Comets experience thrust as solar heating causes gases to erupt from their surfaces, but the direction of thrust from outgassing is strictly determined. The force pushes opposite the direction of material ejection. And all images of 3I/ATLAS show its tail streaming directly away from the Sun. Outgassing should push it slightly inward toward the Sun. What we observe is the opposite, an acceleration outward toward Earth. Not only that, the magnitude of thrust required far exceeds what the observed mass loss rate can produce. We would need outgassing at nearly 6 times the measured rate to generate the acceleration we're seeing. That is physically impossible unless the tail we see is a decoy, which itself is an uncomfortable idea to consider. Solar radiation pressure is another potential explanation. Photons do carry momentum and can push lightly on objects with large surface area, but calculations performed by Dr. Nadia Sullivan at Caltech show that even under extremely favorable conditions, assuming the object is perfectly reflective and unusually low density, the maximum possible acceleration from radiation pressure is still an order of magnitude too weak gravitational perturbations. Simulations including every planet, dwarf planet, and major asteroid in the solar system were run by Dr. Arjun Rao at Oxford. The perturbative effects not only failed to explain the anomaly, but actually make the mismatch worse. After exhausting the known forces of nature, the scientific community arrived reluctantly at the one explanation that fits the data without requiring new physics: a sustained, directed force, thrust, propulsion, and propulsion implies intention. When Dr. Evelyn Morales at the European Space Observatory analyzed the fine structure of the trajectory deviations, hour-by-hour variations in acceleration, she found something extraordinary. The thrust wasn't smooth. It pulsed, it paused, it resumed, it shifted direction slightly at predictable intervals. It behaved exactly like a low-thrust propulsion system optimizing its delta-V budget, similar to ion engines used on our most efficient probes. Small bursts of acceleration, followed by long coasts, intermittent corrections, thrust vectors that adjust to real-time measurements. This is the hallmark of closed-loop navigation with onboard guidance and active control. In simpler terms, something aboard 3I/ATLAS is flying it. Now, before we leap to the most dramatic interpretations, we must acknowledge that artificial propulsion does not prove intelligent origin. It could be a derelict probe, a relic from a civilization long gone, following an ancient guidance program. It could be an automated vehicle on a mission whose designers never intended to revisit it, but regardless of its origin, propulsion means design. It means engineering. It means purpose. More unsettling still is what the direction of its course corrections implies. Without the anomalous acceleration, 3I/ATLAS would pass Earth at a distance of about 0.06 AU, or around 9 million kilometers. With the current adjustments, the closest approach is now projected to be roughly 3.1 million kilometers, half the original distance. And the date has shifted from January 2nd to December 29th. Objects do not accidentally optimize for a closer approach unless they are being told to. We are watching trajectory corrections consistent with targeting. The closer we examine its behavior, the more disturbing the implications become, because the course corrections made by 3I/ATLAS are not random, nor are they merely about minimizing energy expenditure. They follow a recognizable logic, the same logic our own mission planners use when preparing a spacecraft for a gravity assist maneuver or a controlled flyby. Dr. Elijah Monroe at JPL performed a full reverse propagation of the thrust profile using algorithms normally reserved for interplanetary navigation. What he found sent a chill through the entire analysis team. The sequence of thrusts matches what one would expect from a vehicle preparing not simply for a close approach, but for a potential insertion into Earth's Hill sphere, the region where Earth's gravity dominates over the Sun's. In human terms, it is positioning itself to be captured if it chooses to be captured, or worse, positioning itself to release something that could be captured. That possibility forced us to revisit the telemetry one more time. The acceleration pulses, those brief periods of thrust that raise its velocity, followed by quiet coasting, aren't just efficient, they are deliberate. Their timing aligns with predicted gravitational gradients along the inbound trajectory. Someone, or something, is measuring the actual environment in real time and adjusting accordingly. Dr. Monroe compared the thrust pattern to the autonomous navigation systems on NASA's deep space missions. His exact words were, "If this is natural, then nature has somehow built a spacecraft." But the question that now looms over every scientific meeting is not how 3I/ATLAS-B is maneuvering, it's why. The first hypothesis examined was reconnaissance. A controlled flyby is the simplest way for an extraterrestrial probe to collect high-resolution data on Earth without risking direct contact. A closer pass shortens communication delay, improves imaging fidelity, and allows sampling of our magnetosphere. But that explanation does not account for a more uncomfortable detail: the timing. December 29th is not random. The date was not chosen for orbital convenience. Several alternative trajectories identified by Dr. Felicity Rhodes at the SETI Institute would have allowed even closer approaches at lower energy cost earlier in the month. Instead, 3I/ATLAS-B is adjusting itself to meet Earth on a date that happens to align with one of the most widely observed human holidays. Is that coincidence? Possibly. But as Dr. Rhodes herself phrased it, nothing about this object's behavior suggests coincidence. Another possibility raised by the Planetary Defense Group is calibration. A probe could be adjusting its trajectory to match pre-existing instructions transmitted long before arrival. If 3I/ATLAS-B was launched centuries or millennia ago, it might be executing a pre-programmed sequence designed to synchronize with seasonal, magnetic, or orbital markers. But that explanation collapses under scrutiny for one critical reason. The thrust patterns are adaptive. They respond to unpredicted perturbations. They compensate for slight variations in solar wind intensity and planetary gravitational phase. No pre-programmed sequence, however sophisticated, could account for physical conditions that could not have been predicted before launch. This is navigation, not playback. And if it is navigation, then something is making decisions. Dr. Eva Nakamura of the European Astrobiology Commission outlined the three broad categories of decision-making we might be witnessing. The first is biological intelligence, an organism or a crew operating the craft in real time. The second is artificial intelligence, an autonomous system executing complex guidance behavior. The third is what she termed encoded agency, a hybrid possibility in which a non-sentient machine is carrying out instructions left by an intelligent species now unreachable. None of these categories are comforting, but each implies a very different kind of arrival. Whatever the case, the implications for humanity are immense. While scientists have been dissecting the physics, governments have been quietly preparing for scenarios ranging from peaceful contact to catastrophic misinterpretation. A classified briefing delivered to the United Nations by the Office of Planetary Security, an office that did not exist 6 months ago, provided a stark assessment. Humanity does not possess the technological capacity to redirect, intercept, or disable an object of this mass and velocity, demonstrating active propulsion. There is no defensive posture available, only observational readiness. That vulnerability creates a tension across every international meeting room. How should we present ourselves? How should we respond? How do we communicate with something that has already demonstrated millions of years of predictive capability simply by arriving here with such precision? The first coordinated transmission will be sent tomorrow using an array of global radio telescopes, broadcasting a unified message across multiple frequencies. The message contains prime numbers, hydrogen spectral lines, mathematical constants, and structural representations of fundamental physics. It is not a greeting, it is not a plea, it is an acknowledgement. We know you are out there, we recognize your presence, we understand the language of mathematics, the grammar of the universe. But behind this hopeful gesture lies a growing unease. Because the more deeply we examine its approach, the clearer it becomes that 3I/ATLAS is not simply visiting, it is aligning. The thrust vectors over the past 3 days have subtly shifted to reduce relative velocity during closest approach. Dr. Monroe described it as pre-braking, the same maneuver a spacecraft performs before entering a capture orbit. If 3I/ATLAS were to release smaller objects, probes, landers, or instruments, this would be the optimal way to ensure they can be inserted safely into Earth's gravitational well. That scenario becomes even more plausible when considering the object's mass distribution. Infrared analysis from the James Webb Space Telescope shows several anomalous thermal gradients, localized heat lacing across its surface that cannot be explained by solar heating alone. Dr. Haruto Sato at the University of Tokyo proposed that these gradients correspond to internal power systems cycling on and off, consistent with docking ports, bays, or compartments adjusting energy load. If the object contains subcomponents, shelters, or deployable modules, this pattern would make perfect sense. Still, we cannot assume hostility, we cannot assume benevolence. We cannot assume anything except capability. What complicates matters further is an emerging signal buried deep in the radio background surrounding 3I/ATLAS. Over the past 48 hours, the Parkes Observatory in Australia has detected faint narrowband emissions, highly regular, pulsed, and not of natural astrophysical origin. Dr. Amelia Sandoval of the CD Signal Processing Unit isolated the pattern. It repeats every 19.4 seconds with a spectral purity impossible for natural sources. It is not noise, she said during the emergency call. It is not artifact. It is intentional. We do not yet know whether the signal is directed at Earth, directed internally within the object, or part of an inter-system communication protocol. But combined with everything else, the thrust, the precision, the timing, it paints a picture that is becoming impossible to ignore. 3I/ATLAS is not just on its way to Earth, it is preparing for something. And whatever that something is, we will face it not in decades or years, but in days. As the hours pass, the situation continues to evolve faster than our ability to process it. The narrowband emissions detected by Parkes have now been confirmed by the Green Bank Telescope and the Sardinia Radio Observatory. The signal is no longer intermittent. It has stabilized into a continuous transmission, still pulsing every 19.4 seconds, but now with a harmonic pattern that grows more complex with each cycle. Dr. Sandoval describes it as a layered signal, something encoding on top of something else. The unnerving part is that the signal's amplitude subtly increases whenever Earth's major transmitters attempt communication. It is, in a way that is scientifically undeniable, responsive. The object is listening. And if it is listening, we must assume it is also analyzing. Our unified transmission, broadcast over the past 72 hours, has almost certainly reached 3I/ATLAS by now. The question that grips every scientist, diplomat, and citizen paying attention is brutally simple. How will it respond? Because silence, in this context, is still a response. Inaction, too, is a decision. And yet we cannot treat this like a conversation with a neighboring nation or a familiar intelligence. We are attempting communication with a presence that may think in dimensions or timescales wholly foreign to us. But something shifted today. At 14:03 UTC, the James Webb Space Telescope recorded a sudden change in the object's thermal profile. 3 of the anomalous heat signatures intensified simultaneously in a synchronized pulse lasting exactly 6 seconds. Dr. Sato compared the pattern to systems coming online. Immediately after the pulse faded, the object's rotation rate, previously stable, began to slow. Not gradually, not chaotically, purposefully. It is aligning a specific face, a specific orientation toward Earth. In aerospace terms, this is targeting geometry. Moments later, a secondary signal appeared, weaker than the primary but unmistakably artificial. Unlike the pulse transmission, this second signal sweeps across frequencies like a radar ping, bouncing off our upper atmosphere and returning faint echoes detectable by our orbital listening posts. It is scanning us, mapping us, measuring our ionosphere, magnetosphere, and atmospheric composition with precision beyond anything we can achieve even from low Earth orbit. Dr. Rhodes summarized it in one stark sentence: they're preparing for operational interaction. The phrase operational interaction has ignited its own firestorm of speculation. Is this preparation for contact, for deployment, for insertion into orbit, for release of probes? Even the most conservative interpretations cannot avoid the chilling truth. 3I/ATLAS is no longer merely approaching. It is actively configuring itself for the next phase of whatever mission it was sent here to accomplish. Governments are moving quickly. Airspace restrictions have expanded. Satellite constellations have been repositioned to avoid accidental obstruction or interference. The International Space Station has been placed into radio silence windows as a precautionary measure. And yet, amidst all the preparation, one unavoidable acknowledgement remains. None of it changes the fact that we are observers, not participants. We cannot control what happens next. The psychological weight of that realization is beginning to permeate the public consciousness. Some communities have turned to faith, seeking comfort in centuries-old teachings newly challenged by interstellar evidence. Others retreat into denial, insisting the anomaly is a media fabrication or a misunderstanding. But for many, there is a quiet, growing acceptance, a recognition that humanity has stepped into a chapter of history no generation has ever confronted. As Dr. Nakamura said earlier today, the universe is asking us a question, and we do not yet understand the language to answer it. Still, amid the uncertainty, there are moments of clarity. A small task force, an international coalition of physicists, linguists, and cognitive scientists, has begun analyzing the harmonic structure of the pulse transmission. Early results suggest that the signal contains deliberate mathematical symmetries, ratios of prime numbers, geometric progressions, and intervals consistent with known physical constants. It is not a greeting in any human sense, but it is a statement of presence, a demonstration of knowledge. In a way, they are introducing themselves the only way a species separated by light years and epochs can, through the universality of mathematics, but the breakthrough, if it can be called that, came only minutes before this briefing. Using cross-correlation analysis, Dr. Sandoval's team detected a micromodulation buried deep inside the primary pulse, a faint cyclic pattern encoded at a much lower amplitude. When reconstructed, the modulation forms a sequence of repeating ratios identical to the structure we transmitted 3 days ago. Not all of it, not perfectly, but enough to identify unmistakably. They are reflecting part of our message back to us. They heard us, and they answered. The implications are overwhelming. This is confirmation not only of intelligence, but of reciprocation. Whether the reflection is a test, a handshake, or a simple acknowledgement of receipt, we cannot yet know. What we do know is that this changes everything. Every diplomatic conversation, every scientific model, every strategic calculation must now adapt to the fact that we are no longer broadcasting into silence. We are engaged in the first two-way exchange with a technological intelligence not of Earth. As I speak, 3I/ATLAS-B is less than 4 million kilometers from our planet. Its trajectory refined, its systems active, its signals evolving with every cycle. In 5 days, perhaps fewer, it will reach its closest point of approach. What happens then may redefine our species, our future, and our place in the cosmos. We are standing at the threshold of an encounter that generations before us only dreamed of or feared. The old question, are we alone, has already been answered by mathematics, motion, and machine-like precision. What remains is the harder question, the one that will echo through every mind on this planet in the days ahead. What do they want? And before long, we will discover the answer, not in theory, not in speculation, but in reality, as 3I/ATLAS completes its silent, deliberate descent into the space between our world and the unknown. The universe has finally spoken now. It is our turn to listen.